Okay, this is an actual rare video. It's not really trig. It's going to help you with geometry because it's a section it's in Algebra 1, but I kind of glossed over it. I maybe did like a day on it, so you probably don't remember it. So I kind of feel bad about that. So I want you to just graph these two lines. They're both in slope-intercept form. So like the y-intercept here is -4. And then from there, that's like 3/1. So you go up 1, 2, 3, right 1. This isn't what your assignment is. It's just making a point. So take your ruler, graph the points. And on that same coordinate plane, graph the other equation. So y equals 3x plus 2. So 2 now is the y-intercept. So you go up 1, 2, 3, right 1. And you're going to notice that those lines never cross. They're parallel. And the reason they're parallel is because they have the same slope. Okay? So same slope means lines are parallel. If you think of a real life problem, if some guy has like $50 and another guy has $30 and they both earn like $3 a month, both of them earn the same amount, well, they're never going to be equal. They're never going to catch up. That guy that starts off with more money is always going to have more money than the other guy. And that's kind of what this is here. If he starts up at 2, but he's at -4, this line's always going to have a higher y value. Okay, now this one's going to be different. Now you notice the slopes are not the same. So you're at 2. Then you go down 2, right 1, 2, 3. Down 2, 1, 2, 3. Okay, so take your ruler. Okay, and then the other ones, these will cross, but something weird happens. So 1, 2, 3, 4, 5, 6, and then you go up 3/2. You can't really do it a second time. It's important you graph these straight with a ruler because they do cross. I don't need you telling me the point where they cross, okay? What they do, though, is form a right angle, meaning they're perpendicular, okay? Now, there's a reason why they were perpendicular, okay? Because if you take the two slopes and multiply them, -2 thirds times +3/2, the product is -1, okay? And that always happens. So slopes equal product of -1. They're always going to, the lines are always going to be perpendicular. It's got to be -1, too. Can't be +1. So here's what you're doing here, and this is going to help you out when you do geometry, okay? It says total row of the graphing are parallel, perpendicular, or neither. So write the words parallel, perpendicular. If you want to abbreviate that, that's fine. Neither. So first off, make sure both the lines are in slope-intercept form, meaning the y has to be by itself. They both are, so the slope here is 1/4. The slope here is -4, okay? Well, they can't be parallel. They have to be the same to be parallel. So you can ditch that. Perpendicular, multiply them, see if it's -1. I think it is because a number times its reciprocal is always 1, and then a positive times a negative is a negative. So they're perpendicular. Okay, the next one, parallel, perpendicular. I've taught this before just last year for whatever reason. I skipped over 2 years ago. I sure didn't do it. Okay. Okay, now you got an issue in the first equation, and that's the fact that the y isn't isolated, but you just have multiplication by 4, so divide by 4. This one I know the slope, because that's in slope-intercept form. The slope's 4/5. Now, when you do your slope, the one in front of the x, it's important if that's a decimal that you just leave it as a fraction, an improper fraction, but think of what a common factor maybe you could divide 5 and 4 by, and there aren't any, so that'll stay -5/4, and that becomes 3. This other one, I don't care if it's a fraction or decimal, but that one in front of the x is where my slope's going to be, so it's important that I don't just put that as a decimal. I guess you could, since whatever. No, just leave it in fraction form. So now I rewrote that the slope here is -5/4. Okay? So you have to sometimes rewrite the equation in slope-intercept form. So they can't be parallel because they ain't the same. Perpendicular, multiply them. -5/4 times 4/5, and that product's -1. So again, we have perpendicular lines. Okay, this one's already good to go. It's in slope-intercept form. So parallel, perpendicular, neither. This will give you a leg up on the competition when you do this in geometry. So the slope here is already 3/4. To find the slope of this line, you have to get the y by itself like you're doing on that test yesterday. So again, I kind of box up the y, get the 4x out of there. Now rewrite that then as -4x plus 9. Okay, then you divide everything by -3. Remember what I told you over here in front of the x, so you have a negative over a negative. Those will cancel, okay? By the way, if you have a negative on the bottom but not on the top, you shift the negative from the bottom to the top. Did you hear that? If you have a negative if the top's positive and the bottom's negative, then you just move the negative to the top, okay? 4/3, don't divide that, it's a decimal. 4/3 don't really have any common factors, so that's in simplest form. I want it to be improper though, -3. And now I can see my slope here is 4/3. So 3/4 and 4/3 aren't the same, so they can't be parallel. Multiply them, it has to be -1, can't be 1. Yeah, that's 1. So they're not perpendicular, so neither is the correct answer here. Okay, next one. This one, I don't know the slope until that 6 has been divided. Put the 1 there. So here, set up your 3 options. That's how I would do it. It makes it a lot easier to go through and examine your options. Okay, so the slope here, you got y equals, again, 1 and 6 can't be reduced. It's -1/6x, and then that's +1. And here I know my slope is -1/6. Here I know the slope already because y is by itself. The slope here is -1/6. And they're both the same, so we have parallel lines. Okay, here, parallel, perpendicular, neither. You're going to notice the last one down here looks a little jacked up. It's right, but it's actually an easy problem. You just got to be cognizant of it. Okay, slope here is 5/5. If you don't want to put the 1 under it, that's fine. You're not graphing it. And the slope here I already have. The slope here is 1/5. Well, they ain't parallel because they ain't the same. Perpendicular, they have to multiply to -1. You know already that they're not going to multiply to a negative given the fact that they're both positive. So that's another neither. Okay, here, sorry I did that to you. Okay, it's kind of irritating. So, slope, parallel, perpendicular. I would abbreviate that, but then there's those idiots who laugh at it, so you can do it how you want, okay? Okay, parallel, your y is not by itself. You don't have to divide, but you have to subtract 6. But I can subtract 6 from 8, and it's y equals 5x plus 2, so the slope's 5. Over here, we have to move the 10x out of here. Rewrite that as 5y equals negative 10x plus 50, and then divide by 5. So that's by itself. Sorry, I wrote that crappy. Negative 2x plus 10. So the slope here is negative 2. That's a dead, you know right away, not parallel. They can't, there's no way that multiplies to negative 1, and neither. Okay, now the last one's an interesting one. Okay. That's the fact that these are both in constant form, meaning they're on this equation we have an x without a y. Here we have a y without an x. Now we know how to graph those. Go here to one of the graphs, just write them down, and I'm going to show you why the answer is always perpendicular. But I want to show you why. Okay, so in this coordinate here, the x is always negative 4. So you can go graph that. So left 1, 2, 3, 4 up 1, left 4 up 2, left 4 up 3. And you people watching this video are very intelligent. You can probably see why it's going to be perpendicular. It's going to form a right angle. Y is 7, 1, 2, 3. So go right 1 up 1, 2, 3, 4, 5, 6, 7, 2, 7, and 3, 7. So they are definitely going to cross, and they definitely do form a right angle, okay? So those equations that are in constant form are always perpendicular. I don't even have to do anything to know that those are always perpendicular. There's no way you can write an x constant and a y constant without... Now, if they're both y's, they're going to be parallel. If they're both x's, they'd be parallel. Both y's would both go like that. Both x's would both go like that, okay? But if they're different variables in the constant form of the equation, it's perpendicular. Okay, that's all I have to say on that. I didn't give you much workspace, just, yeah, sorry about that.